This would be a level 2 question. The sum of the roots of the quadratic equation ax square plus bx plus c equals 0 is equal to the sum of the squares of their reciprocals. If a, b, c are real numbers and a not equal 0, then we have to find bc square, ca square and ab square are in gp, ap, hp or none of these. Now the first thing that we do is say let the roots are x1 and x2. So the sum of the roots, that is x1 plus x2, is minus b upon a. Similarly, the product of the roots, that is x1, x2, is c upon a. So from here, by the question, we have x1 plus x2 is equal to 1 upon x1 squared, that is 1 upon x1 squared plus 1 upon x2 squared. From here, I can say it is x1, x2 whole squared, and my numerator is x2 squared plus x1 squared. Now x2 squared plus x1 squared is x1 plus x2 whole squared minus twice of x1 x2. So from here I can say now x1 plus x2 is, so minus b upon a is equal to x1 plus x2 whole square, that is b squared by a squared minus twice x1 x2, that is 2c by a, whole thing upon x1 x2 whole squared, that is c squared by a squared. So upon simplification we see that we get minus b by a is equal to, so here b squared by a squared minus 2ac it would become, so it becomes b squared minus 2ac, b squared minus 2ac upon a squared. This whole thing divided by c squared upon a squared. So I can say that it is multiplied by a squared upon c squared. So a squared get cancelled out. So we are left with minus b upon a is equal to b squared minus 2ac upon c squared. That is b squared minus 2ac upon c squared. So from here we get that 2 a squared c, or I should say ac squared, c a squared or a squared c, whatever, is equal to b squared plus bc squared. So that would mean that 2ca squared is equal to ab squared plus bc squared. So that means that ca squared is the arithmetic mean of ab squared and bc squared. That means ab squared, bc squared and ca squared lie in an AP or form an AP. Answer is option B.